Find the derivative using implicit differentiation. So we have the function on the left side. We're going to take the derivative with respect to x of e to the x over y, and that's equal to the derivative with respect to x of 3x minus y. Okay, so when we take the derivative of e to the xy, we're going to have to use the chain rule. So we know when we take the derivative of e to the xy, we're going to get e to the x divided by y. And then we're going to have to take the derivative of the inside function, which is x over y. So we're going to have to take the derivative of that. And then that's going to equal the derivative with respect to x of 3x. So the derivative of 3x is going to give us 3. And then the derivative of minus y is minus 1 times y prime. Okay, so now if we take a look at what we need to take the derivative of now, so we have e to the x over y. Well, here we have a quotient. So we're going to have to take the derivative of x over y using the quotient rule. So we have low, which is y, times the derivative of the high. So the derivative of the numerator is going to be 1 minus high, which is the numerator, times the derivative of the low, which is 1, times that implicit differentiation, over the denominator squared, which is y squared. And that's equal to 3 minus y prime. Okay, so let's simplify what we just did with the quotient rule. So we have e to the x over y, and then when we simplify, we get y over y squared minus x times y prime over y squared, and then that's equal to 3 minus y prime. Okay, and now we're going to simplify that y over y squared. So we have e to the x over y times 1 over y minus x y prime over y squared, and then that's equal to 3 minus y prime. Okay, so what we want to do is we want to solve for y prime here. In order to solve for y prime, we're going to have to distribute this e to the xy and then isolate that. So therefore, if we distribute this e to the xy, we have e to the xy times 1, which is e to the xy over y, minus we get x times e to the xy times y prime over y squared, and that's equal to 3 minus y prime. Okay, so what we want to do is our goal is to eventually get our y primes on one side. So if we want to eliminate, let's say, the denominator, when you think about fractional equations, we can multiply everything by the LCD. So if you notice here, the LCD is going to be y squared. So if we multiply everything by y squared, then we're going to get the following. So y squared times the first term, y squared divided by y, is going to give us y, times e to the x over y, minus y squared divided by the second term. Y squared divided by y squared is going to leave us with x e to the x over y times y prime. And then if we take y squared and multiply it by those three terms there, we're going to get 3y squared minus y squared times y prime. Now our goal is to get y primes on one side of the equation. So we're going to add that negative y squared y prime. So we're going to get y squared y prime on the left side of the equation, and then minus x e to the x over y times y prime. And then we're going to subtract the y e to the xy, so minus y e to the x over y power. Now we can factor out the y prime in step number 8. So if we factor out the y prime, then we end up with y squared minus x e to the x over y power, and that's equal to 3y squared minus y e to the x over y. And then we're going to divide both sides by y squared minus x e to the x over y. We get y squared minus x e to the x over y. And therefore, we end up with y prime, which is equal to 3y squared minus y e to the x over y divided by y squared minus x e to the x over y. And therefore, there is our derivative, solving it implicitly for this particular problem. Now, with this particular problem, we can also rewrite this so that we can factor out a y. If we factor out a y in the numerator, we would have 3y minus e to the x over y divided by y squared minus x e to the x over y. And therefore, that's another solution that's equal to that.